All right, so we're going to go over the three types of distributions that we've gone over in this unit in preparation for our test. So I'll kind of go over a summary of each of them and then let you practice along the way and check your answers on Schoology. So the first type of distribution that we did was our probability distribution. And remember, there was two requirements for our probability distribution. That the sum of all probabilities equals 1. So I would want to add these up and make sure that it equals 1. 0.56 plus, which it does, so that's good. That meets the first requirement. And then that all probabilities are between 0 and 1. So that means you have no negative probabilities because there's no such thing. And then there's no values greater than 1. So all of these are between 0 and 1. So we've met that requirement there as well. So if I want to graph my probabilities, remember we just put our x's or our outcomes over here and our probabilities on this side. So I have 0, 1, 2, and 3 as my outcomes. And then remember, when you're counting up your probabilities, you have to be consistent in what you're counting by. You can't just pick random values along the way. You have to consistently count by the same amount for each marker so that you can actually see the difference in height. So I would probably count by 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. So then with the outcome of 0, I have a 0.56, so that would be like this. 1 has a 0.15, so between 1 and 2. 2 has a 0.27. And 3 has a very little probability of 0.02. So that would be what my graphing my probability would look like. So then a couple of things that we did in this unit, or the couple of things we could do with our probability distribution, was finding our mean and our standard deviation. So remember, to find our mean, we would multiply x times p of x and then just add them all together. So I'm going to multiply x times p of x. So I'll multiply 0 times 0.56, which would just give me 0. 1 times 0.15 would just give me 0.15. 2 times 0.27 gives me 0.54. And 3 times 0.02 gives me 0.06. So I multiplied all my x values times my p of x, and I'm just going to add all those values together. I'm not going to divide. This is not that kind of mean. This is a distribution mean. I'm just going to add these all together, and that gives me my mean value. So then to find our standard deviation, we're going to do x squared times p of x, but that's not the only part of this equation. So we're going to find this part first, but remember, that's not going to be our final answer. So if I do x squared times p of x, 0 squared is just 0, times this would still give me 0. 1 squared, right, if I want to type it in my calculator, 1 squared times 0.15 would still give me 0.15. 2 squared times 0.27 gives me 1.08, and 3 squared times 0.02 gives me 0.18. So I'm going to add these values together. So 0.15 plus 1.08 plus 0.18, and I get 1.41. Now that is not my standard deviation. That's the value that you get for this part here. So I still need to take the square root of this number minus my mean squared. So minus my 0.75 squared. So I'm going to take the square root, the square root of 1.41 minus, and then my 0.75 squared. And that will then give me my mean, so my standard deviation. So my standard deviation here is 0.92. Okay. The other piece to this is finding unusual values, which for us is just if it has a probability of 0.05 or less. So we don't have to do any kind of math to calculate it. All we're going to do is look for values in our table that are 0.05 or less. So for instance, right, x equals 3 would be considered unusual because my probability is less than 0.05. Okay. So now moving on to our next part. The other thing that we did with probability distribution is we talked about expected values. Remember, expected values is the same thing as the mean. It's just written in some sort of context to a problem. So for the example we're looking at, it says you're required to purchase car insurance. You pay $850 a year for it. The probability that you don't get in a wreck is 0.85. The average amount of money given in a wreck is $3,000. Find the expected value. So the only possibilities that happen in this situation are that you wreck or you don't wreck. Right? Those are the only options for this problem. So then if I wreck or if I don't wreck, how much money, event in numbers just means how much money went into this. If I don't wreck, right, I paid $850 in insurance that I'm not going to see back. Right, I just paid it. I didn't need it. It's gone. If I do get in a wreck, I paid my $850, but now I'm going to get $3,000 back. So I'm actually going to profit if I do $3,000 minus $850, right? It's not, you don't get the full $3,000 back because you put $850 in. So you're really only going to get $3,000 minus your $850, which is $2,150. So you end up profiting $2,150. Okay, so now we need to know the probability of each of these events happening. So the probability you don't get in a wreck is 0.85. Now remember, these two have to add up to 1 when I'm all said and done. In a probability distribution, the sum has to be 1. So if this is 0.85, then this would need to be 0.15 so that they add up to 1 at the end. Okay, so now to find my expected value, again, it's the same thing as finding my mean that I did up here. I'm doing x times p of x, and then I'm going to add them together. So I'm going to do 2,150 times 0.15, and I get 322.5. And then I'm going to do negative 850 times 0.85, and I get negative 722.5. So when I add these two up together, I get negative 400. So my expected value is that I'm going to lose money in this situation. Right? There's a higher probability that I'm not going to wreck, so I'm just going to lose money. I'm averaging that I'm going to lose money every year. Okay, so you should pause this video and try the next two, or try this section here just to practice some probability distribution, and then you can check your answers on Schoology. But now I'm going to go ahead and turn the paper over, and we're going to look at binomial probability, which was our second type of distribution. So for our binomial probability, remember there was only 2 outcomes that can come out of binomial probability, success or failure. In our probability distribution, we could have as many outcomes as we wanted, right? We could have 0, 1, 2, 3, all the way for as ever long as we want. This one, there's only 2 options. You either did it or you didn't. So remember, to help us find our binomial probability, we used this function in our calculator, and we'll look at some examples of why we need this in a second. And then we used these to find our mean, standard deviation, and then our unusual results. So let's go ahead and look at some examples together. So Rory McIlroy has a 52% chance of completing each hole scoring par. If he golfs for all 18 holes, what is the probability he scores par for exactly 10 holes? So again, to do our binomial probability, we need three things. We need our total number of chances. We need our probability. And they call this trials in our calculator, our total number of trials. And then this is the outcomes that we're looking for. So if we look back at this problem, right, my probability is 0.52. I'm going to go for all 18 holes. So my total number of trials is 18. My probability is 0.52. And then I want to know what's the probability I score exactly 10. So my outcome would be getting 10 for my X value. So I'll go ahead on my calculator and go to second vars. I got to go all the way down to binom PDF, which for most of you is letter A. It might not be A on every calculator, but should be near A. So my number of trials is 18, my probability is 0.52, and my X value is 10. So then when I calculate that, my probability of getting exactly par on 10 holes is 0.1782. Okay, so when we look at the next one, it says, what is the probability he scores par for at least 16 holes? So, again, my total number of trials is 18. My probability is 0.52. At least 16 holes would mean 16 or more. So that means I could have 16, 17, or 18. So I'm going to have to find all three of these probabilities and then add them together. So when I do that on my calculator, and I can use, right, if I just go up and highlight this, I still have n is 18, p is 0.52, and I'll make this 16. So that's probability of 16. And then I can change this to 17. Right, all I have to do is go over and highlight it, hit enter, and then it'll bring it down in a way I can edit it. So then I'll make it 18, and then this is 16, 17, and 18. So I want to add those three together. So I'm going to copy this one down, hit plus, copy the next one down, hit plus, and copy 16 down. So I get that the probability would be 0.0011. So now if I want to know the mean and the standard deviation, to find in our binomial probability, our mean is just our n value times our p value. So I'm just going to multiply 18 times 0.52, and I get that my mean is 9.36. That's all I got to do is multiply n times p. To find my standard deviation, I do the square root of n times p times q. So I know n and p, I just need to find q. So I know, right, and remember, q is just the failure rate. So if you have a 52% of being successful, your failure is the other 48% of that, right? So q you can also find by just doing 1 minus p, but it's just what's the percentage that you don't get what you want. So n is 18. My probability is 0.52, so my failure rate is 0.48. So if I do the square root of 18 times 0.52 times 0.48, I end up with 2.12 as my standard deviation. Okay. So that's my mean and my standard deviation. So now if I want to find an unusual result, I'm going to end up using this equation here, which says I'm going to take the mean plus or minus 2 standard deviations. So I'm going to do the mean plus 2 standard deviations and the mean minus 2 standard deviations. So here I would do 9.36 plus 2 times 2.12, and then 9.36 minus 2 times 2.12. And I'm just going to calculate those values on my calculator. And then 9.36 minus 2 times 2.12. So I get 13.6 and 5.12. This means that values within the range of these two numbers are considered to be usual results. We expect values between 5.12 and 13.16. So anything outside of that would be considered unusual. So since 4 is outside of this range, we would say yes, 4 would be unusual. And then why it's outside of our range of our 2 standard deviations. Okay, so there's some bottom questions for you to try exactly the same thing, just for you to try on your own, and then you can check your answers on Schoology. But now I'm going to go ahead and move over to our last type of distribution, which was our normal distribution. So in normal distribution, the first thing that we went over was the empirical rule. Remember, normal distribution, our probabilities all came from the area underneath our normal distribution curve. So the first thing we could do was just based off of the empirical rule, there were some percentages that we already know just based off of that. So this says a freshman at CSU took a biology exam. The scores were normally distributed with a mean of 70 and a standard deviation of 5. Label the mean and the values up to 3 standard deviations away from the mean. So our mean is 70 and our standard deviation is 5. So I'm going to count up by 5 on this side and then down on this side. So remember, our empirical rule said if we're 1 standard deviation away, then we're 68% of the area is 1 standard deviation away. 95% of the area is 2 standard deviations away. And then 99.7% of the area is 3 standard deviations away. So the first question asked between 65 and 75. So I'm just 1 standard deviation away on both sides. So my empirical rule tells me that's 68%. Then between 60 and 80, that's 2 standard deviations away on both sides. So my empirical rule says that's 95%. Now here's where the problems got trickier. This one is asking between 55 and 80. So 55 is over here, 80 is here. So on this side, starting at the mean, I'm 3 standard deviations away on this side, but only 2 standard deviations away on this side. So if I'm 3 standard deviations away on this side, right, we're only 3 standard deviations away on half of the graph. So I'm going to take my 3 standard deviations, my 99.7, and divide by 2. That accounts for this half of my graph. Well, then on this half, I'm 2 standard deviations away, which my empirical rule says is 95%, and I'll divide by 2. So if I do 99.7 divided by 2 and 95 divided by 2, and I add those two up, it tells me that my percentage is 97.35%. All right, so then my next one says what percentage of scores are less than 75%? So it's actually cutting us off here, and it wants all the values less than 75%. So if you think about this, right, I'm going to cut it off at 75. Well, at 70, the rest of this graph makes up 50% or 0.5, right? If I, at the mean, that cuts my graph in half. So this part would be 50%. So then I just need to figure out what this little sliver is here. Well, this is 1 standard deviation away on one side. So then I would do my 68% divided by 2. And that would give me 34. So if this is 34 and this is 50, right, 50 plus 34 would give me 84%. So all of these areas we could find based off of our empirical rule. Well, we're not always given values that fall within our empirical rule, so we have to be able to find them other ways as well. For instance, one thing that you can do is you can put everything into a standard normal curve. So a standard normal curve just means it has a mean of 0 and a standard deviation of 1. And we do that by finding its z-score. So to find a z-score, here's how we find a z-score. We take our number, subtract it from the mean, and divide it from our standard deviation. That just gives us a value on our standard normal curve. So for instance, for this one, if I want to find the z-score, I would take my value, subtract it from the mean, and divide by the standard deviation. So 89 minus 81 divided by 4.2 would give me a z-score of 1.905, really, when I round that. So then when we're talking about our standard normal curve, right, we have our mean of 0, our standard deviations of 1. Anything between -2 and 2 we consider to be normal. Anything outside of those values we consider to be unusual. So getting a value greater than 2 to be over here or less than -2 to be over here would give us unusual results. So this would not be unusual because it's within our 2 to -2 range. So the real reason we find z-scores, is when we have two sets of data that we're trying to compare and they don't have the same information. So they don't have the same mean and standard deviation. We can get them z-scores to place them on our standard normal curve. And then that will kind of tell us where they are in comparison to each other. So it says the height of an American male has an average of 69.1 with a standard deviation of 2.8. For females, the mean is 63.7 with a standard deviation of 2.5. Which person has a higher relative height? A 67-inch female or a 72-inch male? So if we compare our male, right, our male has a height of 72. Their mean score was 69.1 and the standard deviation was 2.8. So we're going to find that z-score for males, and then we're going to do the same thing for females. So our particular person has a height of 67 with a mean of 63.7 and a standard deviation of 2.5. So when we find both those z-scores, what it's going to do is it's going to place us on a standard normal curve that we can then compare results. So when I find the male, 72 minus divided by 2.8. So I get 1.036. So that's right about there. So then when I find my female score, 67 minus 63.7 divided by 2.5, I get 1.32. So that would be a little bit past that. So when we look at this on the same curve, we realize that the female score is farther over to the right, which means that they have a higher relative height, right? They have a greater value on the z-score than the male. So the female is relatively higher or taller. I should put relatively. She's obviously not taller, but in terms of her height, that would make sense. Okay. So then the last part of this was finding the probability given values, finding the area under the curve. Remember, the first ones we did were off of our empirical rule, but not all of our values are going to fall within a standard normal curve, or not all of them are going to fall within a 1 or -1. We can have decimals and such. So our calculator allows us to still find the probability or the percentage, but with decimals or things of that sort. So this is what we're going to use on our calculator. So when I draw out my standard normal curve, Remember, the mean is always 0. The standard deviation is always 1. So then if I want a score of less than negative 1.5, right, negative 1.5 is about there, and I'm trying to find the area or the probability of everything below that. Okay, so when we do our normal CDF, we need our lower bound and our upper bound. So that just means of the shaded region, what's the lowest number you're shading and what's the highest number you're shading. So since we're shading all the way to the left, remember we're going to go 1e to the 99 to represent shading all the way to the end of this graph. And then I'm shading until I get to negative 1.5. And then in my standard normal curves, my mean is always 0. My standard deviation is always 1. So when I do this on my calculator, I'm going to hit second vars, and then I go to normal CDF. I'm going from negative 1e to the 99 to negative 1.5. My mean is 0. My standard deviation is 1. So then the area underneath my curve is 0.0668. Okay, so then if I want to find the area between negative 1.43 and 0.36, and again, this is just like an estimation when we're drawing. It does not have to be exact or perfect. We're just looking for the right area, right? We're just looking for that area there. So the sketch is simply a sketch. I'm not going to dock you points if it's a little too far to the right or a little too far to the left, but you should know that 0.36 is greater than 0. And negative 1.43 is less than 0. So then when I do my normal CDF, in this case, my lower bound is this negative 1.43. The upper bound is 0.36. My mean is still 0. My standard deviation is still 1. So I'll go back to here, second vars, normal CDF. I'm going from negative 1.43 to 0.36, mean is 0, standard deviation is 1. So the area underneath my curve is 0.5642. All right, so then for this last example, it says it's greater than negative 0.49. So that would be somewhere roughly around there. And I want all the values greater than that. So I'm looking at the right side of my curve. So then I go 1e to the 99 this way. Right, when I go to the left, it's a negative 1e to the 99. When I go to the right, it's positive 1e to the 99. So when I do my normal CDF, my lower bound is my negative 0.49. My upper bound, I'm going all the way to the end of the graph. My mean is 0. My standard deviation is 1. So I'm going from negative 0.49. Oops, that's not right. And then I'm going 1e to the 99. And I get that my area is 0.6879. So that's how we can find the area underneath our normal distribution curve if our curve is standard normal. Our mean is always 0. Our standard deviation is always 1. We can find it with different means and standard deviations. The process doesn't change, just what we're typing into our calculator does. So if we look at an example here, the ASVAB is an aptitude test given by the U.S. military. The mean score is 50 with a standard deviation of 10. So if I look at my normal curve, my mean score is 50, and then my standard deviation is 10. So it looks something like this on my curve. To be eligible to join the Air Force, a person needs a score of at least 36. So 36 would be right about there. So if you scored higher than a 36, you would be eligible. What is the probability that a random person taking the test will not be eligible to join the Air Force? So we're talking about not eligible, right? A 36 and above makes you eligible. So we're actually looking for this area here that represents people who are not eligible. So we're still going to do, I'm still looking for the area underneath this curve. So I'm still going to do my normal CDF. I'm going from -1e to the 99 because I'm shading all the way to the left. And then my highest point was 36. My mean here is 50 now, and my standard deviation is 10. So now this is what I'm going to type in to find my area. So -1e to the 99, 36, mean is 50, standard deviation is 10. So the area would be 0.0808. Represents the probability that someone doesn't pass. All right, so I think there's one more example for us to go over, which is when we have the area and we want to know our cutoff score. And then I'll let you try the rest on your own. So the scores on a test have a mean of 85 and a standard deviation of 10. All right. If a personnel manager wants to select the top 75% of applicants who take the test, find the cutoff score. So if I want to know the top 75%, that means I want to know this shaded region. I want to know what score, what X value is going to put the top 75% of the area together, right? Anytime we're talking about top, we're going to come from the right. And I'm trying to figure out what is that cutoff score that everyone higher than that score is in my top 75%. So there's two ways that you can do this, and it kind of depends on your calculator. If you have a newer calculator, right, I want the top 75%. My mean is 85 and my standard deviation is 10. And the top 75% is coming from the right part of this graph. So my tail is to the right. So if I go second vars and then I go to NV norm, my area is 0.75, my mean is 85, my standard deviation is 10, and I want to go from the right. So that means that cutoff score, right, that value right there, and I wasn't great when I estimated it, but the value right there would be 78.25. Now, if your calculator doesn't let you pick to come from the right, that just means your calculator is always coming from the left. Remember, we're still just trying to find this location here, so it doesn't matter what end of the graph that we come from. But if we had to go 75% this way to get here, that means from the left, we would be going 25% or 0.25. So if I calculate NV norm of 0.25 with a mean of 85 and a standard deviation of 10, and then again, your calculator won't even let you say left. It's always assuming that it's coming from the left. But it will give you the same value because it's just coming to that X spot from the other side. It's just meeting you from the left side instead of the right side. So you have to do it one of those two ways. Okay, so go ahead and finish up this. You finish up this review packet. You can check your answers on Schoology. If you can do everything in this review packet, you should be pretty set for your test next class.